Hi, Georgi Romanic here. Welcome to Fundamentals of Weather and Climate playlist. Global average temperature on this planet is 15 degrees Celsius close to the surface. And we know it would be much colder if we had an atmosphere that doesn't contain greenhouse gases. In fact, the surface global average temperature would be negative 18 degrees Celsius, namely 33 degrees Celsius below what we actually observe around us. And that's because of greenhouse gases. So we are very thankful for the atmosphere and greenhouse gases to keep our planet warm. However, it doesn't mean that every place on this planet has average temperature of 15 degrees Celsius. Some locations are warmer, some are colder. And that's what we are going to discuss in today's video. Here we have a map of surface or 2-meter air temperature averages calculated for the period 1991-2020, 30 years. And this is for the month of January. X-axis is longitude, this is latitude, and the temperatures are given in kelvins. Notice that the tropical regions have warmer temperatures than the polar regions, as we discussed in great detail in one of my previous videos, and then subtropical and mid-latitudes are intermediate temperatures. Over the ocean, the isotherms, which are these lines that connect points of constant temperature, are stretching west-east. Namely, we call that zonal direction. And then irregularities over oceans are land are much bigger. The biggest irregularities are along the coastlines, typically where the ocean meets the land, because temperature properties of these two surfaces are profoundly different, or I should say heat properties. Notice that the temperature range is between 240 and 310 kelvins. Now, if we present the same temperature range and the same map, but for July, not January, but for the summer month, then what you will notice is that temperature difference between tropical regions and polar regions is much smaller than what we had in winter, because the range is the same. Look, in winter, polar regions are much colder than the tropical regions. In July, polar regions are still substantially colder than tropical regions, but not as cold as in the winter season. That is because when we look at northern hemisphere, you know from my videos on the season, when we have winter in northern hemisphere, that means that the northern hemisphere is pointing away from the sun. Now, the tropical regions are always very exposed to the sun, so tropical regions are always warm. But when we have winter in northern hemisphere, and the northern hemisphere and North Pole in particular is pointing away from the sun, then it gets substantially less solar radiation. In fact, it gets zero at the North Pole. And therefore, the temperature difference between North Pole or polar region and tropical region is much more pronounced in winter months, as you can see here in this climatology, compared to the summer months. This is also observed by the fact that in summer months, these isotherms are not very closely spaced. There are only few colors, we could say. But in January, there are many colors, which means that the temperature range between polar regions and tropical regions is substantial. Now, of course, I picked January and July as representatives for winter and summer respectively in northern hemisphere, but we could also calculate average annual temperature, averaging January to December, and this is what you would get. You can see that the range of temperatures between tropical and polar regions is intermediate compared to what we had for the winter and summer months. Yet another way to represent the Yet another way to represent these average temperatures is if we plot here month and we plot here temperature, this time in degrees Celsius. So here are average surface temperatures globally for the last many years, since 1979. So each of these great lines is a given year. You can see we have cold winters and we have warm summers. And then these black lines are average, climatological average for a 30-year period, 1991-2020, 1981-2010, and 1979-2000. So you can see averages of these gray lines. Now, the orange line is year 2024, namely last year. I'm recording this in 2025. And you can see 2024 was clearly warmer than average year. And the thick red line is currently year 2025. We came up to July, and you can see 2025 is also warmer than an average, climatological average of 30 years, but yet 2025 is not as warm as we had 2024. Indeed, 2024 was the warmest year on record, and I discussed that in greater length in my video on record low and record high temperatures for this planet. So what I discussed here is basically summarizing concepts from many previous videos and presenting them in the graph and maps that are typically used in atmospheric sciences and climatology research to present this type of information. Please make sure to like and subscribe, share video, comment, that helps a lot, and until next video, goodbye.